I'm going to share my screen. We have here let's start from let me try this. Okay, we try with let report from K to G. Okay, so I'm going to share the screen. Okay, I'm going to share the screen now. Share. Okay. Can you see my screen now? Someone please respond. Can you see my screen? Okay, yes, okay. Thank you. Okay. So what we have done last time, basically, you're checking in recombinant protein expression or any enzyme assay, why you need to perform this enzyme activity assay, because every time you assay or break the cell or extract the sample, you need to share your content. Okay. What is this? Oh, okay. So you suggest me to use it? Okay, thank you. I don't know this one exists. Okay. So every time we extract the sample, we can see that why I cannot move my cursor anymore. How can I stop this? How can I move this page? You're giving me this pen, then I don't know how to do it. How can I move this? Remove this. Okay, I will remove for a while. Okay. I will use this mouse if you are okay with this, because I cannot scroll down if I use that pen. Okay. So now every time we extract the sample, okay, we need to know that sample, whatever source of the sample, if you have the sample from plant or bacteria or from microbe or even from mammalian cell and everything. Once you have extracted the cell, the protein or the enzyme, you need to do the lattice assay. I mean, you need to do the enzyme assay. Okay, enzyme assay is used to measure if there's any active enzyme in the extracted sample. So that's why the first thing to do once you have extracted the sample, you need to extract. I mean, you need to do the enzyme assay. Okay. In our case, last time we extract the sample from E. coli, and then we inside this E. coli, basically we are looking for lipase enzyme. Okay, lipase is an enzyme. So we want to measure is there any active lipase activity inside the E. coli. So what happened? We break the cell. What method have we used? Okay, we use sonication method. After sonication, yeah, we use this sonication with centrifuge to separate. Okay, sonication is the process where you break the cell using the sound. Okay, once the cells are broken, it is not compulsory to use sonication. You can use any other chemical extraction or any other physical extraction. There are a few techniques out there. So you can choose whatever technique is the most suitable for your sample. Okay. So for our case last time we used sonication method. We're going to break the cell using sound. Okay. So now, once we have extracted the cell, okay, the cells, of course, will be broken. Once the cell is broken, everything inside the cell will be released to the buffer, I mean to the environment. Okay, so what happens, we centrifuge the cell, and then to separate, okay, to pellet down all the broken cell, all the debris. Okay, and then we transfer, I mean the supernatant just now, we transfer to a new beaker, to a new container. So this supernatant, which contain this I mean whatever things coming from out from the cell. Not only protein may be released, we have also some DNA there. So some metabolites will also be extracted at that time. Inside this, whatever compound that we have extracted just now, it is called crude. Okay, it is crude enzyme. Crude enzyme meaning that our lipase now is in the mixture of other things in the cell. I mean, in supernated. Okay, so now we are going to measure. Even though inside this container, inside this beaker, we have many things meaning that, like I told you just now, we have the metabolites, we have the DNA, we have other proteins. Okay, all of this we call impurities. So we are going to measure, is there any lipase in this container? Okay. You cannot control the shape content until you start annotation. During the annotation, you cannot control. Okay, I will try to use this. Okay, so this crude lipase is basically, okay, this is your cell. Okay, I repeat, and then you break the cell now. Okay, you break the cell. How I change? How to change this color? Okay, we break the cell. Break the cell using sonication. Okay, once the cells are broken, okay, then we perform sonication. Okay, sonication. This is hard to write from here. Okay, this is called sonication. Okay, okay. So once we have sonicated the cell, okay, what left? We are going to spin down. Okay, spin down. This spin down process of centrifugation, spin down. Okay, this spin down or centrifugation, can I write here? Oh, okay, we can. First time, sorry. Huh? I lost it. Okay, never mind. I will use the other one. Can I create? Can I open a new file here? Okay, so I'm going to put here. I'm going to put here. Where's the? How can I get back the pen? So if you found, what is her name just now? Can I get the pen back? How? Okay. So you have the E. coli here. Okay, don't forget inside this bacteria cell we have this protein. Okay, we have this protein. Okay, our protein is inside the cell. And then not only protein, we have also some metabolite. Okay, we have also some metabolite here. Okay, metabolite, I label it as green color. Okay, this metabolite also there. Okay, So inside the cell, we may have protein, metabolite, and the DNA. Okay, and then also we have the other blue color represent the other proteins. Okay, the other proteins. It is mixture of protein. We have also other protein. Of course, the other protein will be more than our protein. Okay, so now what happened? We want to know, we want to measure the activity. Is there any lipase? Because we are looking for lipase now. Is there any lipase inside the cell or not? So what's next? We will break the cell. So we break the cell using sonication technique. Sonication. Oh my god. Okay. Sonication. So sonication is the process to break the cell using sound. Okay. What's next? We have got this. We're going to centrifuge. Okay. We spin down this. Okay. So we spin down. Okay. We spin down this. And then what do we have inside? We will have everything inside the tube. Okay. We will have this metabolite. Okay. We will have the protein impurities. Okay, the impurities. And then we also have the lipase, the protein that we want. Maybe a lot of other things here, okay. And then not to forget, we will have also the DNAs. Okay, this is DNA, the genomic DNA. So this is what we have in our sample. Oh, not only that, we will have the cell. The cell debris. The membrane. Okay. Okay. So what's next? Okay, we're going to centrifuge. Once we have centrifuge, okay. Right. Okay, centrifuge. Okay, I don't want this. Not this. Okay, I don't want this. So once we have centrifuge the sample, okay, we're going to transfer all of this into a new beaker. So we're going to transfer into a new beaker, new container. So what do we have inside this container? So inside this container, same. We're going to have this DNA. We're going to have the lipase. But everything will be colorless, right? So we will have this lipase. We will have the metabolite. Okay, metabolite also there. So metabolite will also be there. Okay, so we will also have the other impurities, the other protein. Okay, the other proteins also there. So this is called crude protein. Crude protein or crude enzyme. Done. We have got the crude enzyme here. So now we want to check either this one, I mean, our lipase here is still active or not. Okay, the extraction, the process of sanitation, the process of spinning, the time given, the number of cells being expressed, it is sufficient or not to give us some activity of this active enzyme. So from here, what we do the lipase assay. So this is where we do the, how can I select everything? How? Annotation, how to, okay. I'm going to use new page. File. Okay, I'm going to, huh? Yeah. Okay. I've lost it. Okay, hopefully it is recorded, right? Hopefully the thing that we shown just now still there. Okay. So now we have this crude. Okay. This is called crude just now. Yeah, we got it. This one. Okay. So from this, or maybe I will just go up there. Okay, then from here, we do the lipase assay. Okay, lipase assay. We cannot. I need to type. Okay. And then from here, we will do the assay. Lipase assay and protein assay. Okay, these two assays, okay, lipase assay we detect only the turquoise color, I mean the light blue color. Okay, the protein assay will detect. Okay, the protein assay will detect the light blue color and then the dark blue colors. Okay, these two assay will not detect the presence of metabolite. Okay, this green color metabolite, and then this is the DNA just now will not be detected by using protein assay or lipase assay. So lipase assay, I repeat, lipase assay will detect the light blue color. Protein assay will detect the light blue color and the dark blue color. So I'm going to put this lipase assay. We detect this. Okay, lipase assay will detect this. Okay, protein assay will detect this. Okay, and also this. Okay, all the proteins. So we can see the difference. In protein assay, we can detect all the proteins. In lipase assay, we specifically detect the presence of our lipase activity. Okay, so what's next? What's next? What you have done last time? You have done the purification. So you purified last time. You have done the protein, enzyme purification. Enzyme purification. Okay. So this enzyme purification, okay. This enzyme purification basically is the process to separate, okay, to separate this, to separate all of them, so that we will have only lipase, okay. Enzyme purification is this process to separate the lipase enzyme from the crude. Okay, from the crude. This is the crude. Okay, it's a process to separate the lipase enzyme from the crude. Okay, I'm going to draw again this one. So that we have only lipase. Okay, the crude, this one. Okay, so I'm going to put the arrow. Maybe this color. So this is the crude. Okay. So yeah, crude here. Okay, now we want to separate this. Then before we start doing the enzyme purification, we need to detect the presence of this. This is more important. Okay, so what we need to do here, okay, we will do the lipase assay. So this is one first. Okay, so this is what you have done. Okay, this is what you have done. The substrate, what do you have inside the substrate? Okay, you use olive oil. So inside olive oil, we have the free fatty acid. And then that free fatty acid in olive oil, we have a lot of oleic acid. Okay, so let's just check the oleic acid carbon chain. Okay, let's just put the oleic acid. Oleic acid carbon chain. Others. Okay. C18, carbon 18. Okay. Oleic acid is a fatty acid which carbon 18. Okay, it has 18 carbon. Okay, it's a long fatty acid. So in olive oil, we have a lot of oleic acid. Okay, so we have we know that for lipase, okay, for triglyceride, okay, lipase act on the triglyceride. And then this is the glycerol. Okay, then we have this. Okay, oleic acid. Okay, so if this is the carbon, if this is carbon 4, maybe it will not be cut by lipase. It will react, normally the enzyme target for C4 is the esterase. Okay, so for lipase, it will target all this long chain. Okay, so it will be maybe C12, and then this C18. Okay, so even though lipase we only cut the long chain carbon, long chain carbon, so we'll just use oleic acid as standard. Okay, so oleic acid. Okay, what is this there? Okay, you can find it later. Okay, so what happened when lipase, the lipase enzyme is not active. the dot enzyme, right? So this lipase will react on the triglyceride. This is called triglyceride. Triglyceride. Okay, triglyceride. Yeah. Okay. Glyceride. Oh yeah. Oops. When is it? Okay. Glycerol. Okay. So lipase will break the ester bond, phosphodiester bond between this. Okay, lipase will break the phosphodiester bond. Which color should I use? Yeah. Why there's no more color? Okay, lipase will attack this position. Okay. Okay. This is where the ester bond. Okay, we have the ester bond here. Okay, so lipase will break this ester bond so that this free fatty acid, okay, it will release the free fatty acid. Okay, I'm going to write here lipase will break the ester bonds and release the free fatty acid. Okay, so now we will measure the free fatty acid because we have um, determined the unit for this. Unit is the definition for unit is the rate of product formation, okay, in 1 minute under standard AC condition. What is our standard AC condition? This is standard AC condition. We use olive oil as a substrate. We use 15 millimolar glycine NaO with pH 9, and then we mix olive oil with the buffer to prepare the emulsion. Okay, and then after that we add the calcium chloride, and then we stop using the calcium NaO. We finally, okay, then we stop the reaction using HCl, and then we put the isooctane. After that, we put the copper pyridine. Okay, that's it. That's the standard assay condition. So, the rate of product formation in 1 minute under standard assay condition. Okay. We have the standard for this. What is the standard for this? We use oleic acid. Okay. For our case, the enzyme is lipase. So, unit definition for lipase will be rate. Okay, unit definition for lipase, the one that we are working now. Rate of free fatty acid formation within 1 minute Okay, under standard acid condition. Okay, because we have used lipase. Okay, lipase is the enzyme, and then the substrate is the triglyceride. Okay, what will the product? What will be the product? Free fatty acid. Okay, so the definition for the lipase activity will be rate of free fatty acid formation within 1 minute under standard acid condition. Free fatty acid formation in one in micromole, okay? In micromole. Okay. This one in micromole. In micromole. Okay. So I lost this. This is like this. Okay, that's it. So now we have this lipase react on the ester bond and release the long chain fatty acid, which is olic acid and carbon 12. Okay, what is carbon 12? You can check. Okay, just Google it. Maybe dodecanoid. Now the dodecanoid is what? Okay. So unit definition is rate of product formation in 1 minute under standard acid condition. And then for the lipase, rate of free fatty acid formation. Free fatty acid formation in micromole within 1 minute under standard acid condition. And then this is the standard acid condition. Okay, so now we are going to see the standard. Okay. So for the standard, we have got this one as the standard. Okay, so this is the standard. If you can see here, we start the standard. This is the free fatty acid. Okay, free fatty acid. This is the free fatty acid standard. Okay, the free fatty acid, the amount of olic acid. Okay, and then the absorbent 750. Yeah, right there. Okay, so we have this free fatty acid here, but we use olic acid. Okay, and then the absorbent we take is absorbent 715. Why 715? Because at this absorbent, in the isooctane, this is 700. Absorbent at 715 is the best, where the absorption at in the spectrophotometer will be the highest. Okay, because 715 will detect the green color. Okay. Okay, so now what we have here, we are going to we have prepared. I have prepared this, and then this standard was given to you. Okay, so that everybody will use this standard. So how do we prepare the standard? We prepare the standard to change this. I'm going to change the color. So we're going to prepare the standard. Okay, this one, first tube, second tube, third tube, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so all these 10. Okay, with different amount of the fatty acid. So for this one, it's around 6. Okay, 6 micromole, 12 micromole, 18 micromole, 24 micromole, 30 micromole. Okay, according to the 18, 12, 18, 24, 30 something, yeah, all this. Okay, we follow the x-axis. We calculate a micromole of the fatty acid. and then mix with the isooctane, meaning that the fatty acid mixed with the isooctane. Here we use oleic acid. Okay, so oleic acid in different amount, in different micromole. Okay, mix with isooctane and 1 ml. Oh, you can edit. In 1 ml isooctane. And 1 ml copper pyridine. Okay. 1 ml copper pyridine. Okay, so we are not going to. I'm going to cut this one. Oh, yeah. Okay, never mind. Mix with 1 ml copper pyridine. 1 ml copper pyridine. Okay. So that's it. Yeah. Oleic acid in different micromole. Okay, we mix with the isooctane and we add 1 ml copper pyridine. So when you have less amount of the fatty acid, okay, less amount of the oleic acid, of course the absorbance will be lesser. When you increase until 66, then you can see the absorbance is higher. Okay, absorbance is up to 1.3 or something. Okay, so that's the way how we prepare the standard. Same, the blank here will be the isooctane, and then the one without any pyridine, without any fatty acid here, just supposed to be 0, but that's okay. It just this because we have mixed with the copper. Okay, we give some reading, but that's okay. So it gives you like intercept at 0.0343. Okay, so this is the lowest, the y-intercept. So from here you can see that as we increase the fatty acid concentration, the concentration amount, then the absorbance is increasing. Okay, so that's it. Okay, so now you have performed. Once we do the ACA last time, just now, lipase ACA, we add on acetylbond, it will release all the fatty acid. So even though it's C12, it will give you the color when we react with the isooctane. So we will measure also this one. Except our standard, we use oleic acid. Okay. So what we have here, the green color will be increased, right? Once the micromole of product is increasing. So same